Welcome to chemistry.
Introduction. Infrared spectroscopy is the analysis of light interacting with molecules. It can be used to measure absorption, emission, and reflection of molecules. It can also be used to determine the functional groups of molecules. A functional group is a group of atoms responsible for the characteristic reactions of a particular compound. Lastly, it can be used to determine the strength of a bond. Stronger bonds and light atoms will normally vibrate at a higher stretch frequency. The following picture shows how we can measure the absorption in the star spectrum. Astronomy is an important part of IR spectroscopy, but we'll talk about that later. What is infrared spectroscopy? Infrared spectroscopy is the study of infrared electromagnetic waves. Spectroscopy means the analysis of light wave dispersion phenomena. For example, when light passes through a prism, it splits into different electromagnetic waves with distinct frequencies. Infrared spectroscopy deals with the frequencies which fall under infrared. As you can see in the picture, infrared is one of the many waves humans cannot see. It is also important to note that visible light is a small portion of the chart of many waves in the universe. History. Infrared spectroscopy started in 1950 by Wilbur Kay. He designed a machine that tested near-infrared spectrum and a theory to describe the results. Carl Norris used it in the analytical world in the 1960s, the decade that infrared spectroscopy became an accepted technique. Now it's important to note that one of the main reasons it became an accepted technique is because of the application of Fourier transformation. Transformation is a tool that breaks down a waveform or function into a simpler representation characterized by sine or cosine. This graph shows at which frequency the maximum number of light passes through the interferometer to the detector. We can use this to measure how much of the beam is absorbed by the sample. Theory. Infrared spectroscopy exploits the fact that molecules absorb specific frequencies characteristic of their structure. Absorptions are resonant frequencies. Infrared light on a molecule can contain enough energy to interact at a molecular level, causing vibrational and rotational changes. For example, a molecule can absorb energy contained in incident light, which would result in faster rotation and more pronounced vibration around the axis of symmetry of a given molecule. Vibrations also inform stretch or bend for each bond. This picture shows some changes that can occur when a molecule begins to absorb some energy. How IR spectroscopy works using an infrared spectrometer. First, you pass a beam of infrared light through a sample. When the frequency of infrared light is the same as the vibrational frequency of the bond, absorption occurs. Vibrational frequencies include symmetrical stretching, antisymmetrical stretching, scissoring, rocking, wagging, and twisting. Examination of transmitted light reveals how much energy was absorbed at each frequency. Analysis of position, shape, and intensity of peaks reveals details about molecular structures such as physical characteristics, molecular structure, and purity level. You can also identify the molecule based on functional group. Each functional group has a different wave number and typical appearance. For example, the OH group occupies a Y peak with a wave number near 3,500. The molecules in the picture are supposed to be moving, but since it's a picture, we couldn't get to move. This picture shows different vibrational frequencies which may occur when the absorption process begins. Techniques. There are two main techniques used for IR spectroscopy. The first one is classic. This is a single transmitting IR wave that's split into two. One passes through the object being analyzed, while the other passes through a reference material. The data is collected and analyzed for changes in frequency, power, and wavelength, etc. This method takes longer because you have to test different wavelength frequencies. The second method is FTIR, Fourier Transformation Infrared Spectroscopy. This is essentially a beam that is shot with multiple frequencies within it. You then calculate the number of major frequency components present in the wave coming from the sample with the help of Fourier transformation, which is essentially a method to numerically check frequencies present in waveforms. This method is cheaper and faster and is more preferred. This picture shows the process of IR spectroscopy using FTIR. As you can see, it goes from interferogram to fast Fourier transformation calculations to spectrum.
Created using Powtoon.